In this video, we're going to be factoring what is called a difference of two squares, or a dots. And the way that we identify what a difference of two squares is by looking at what you see here in step 1 to factor a difference of two squares. So if all three of those pieces that you see under step 1 are present, then you can factor the binomial or the polynomial that you see in the ways that you see in steps 2 and 3. The first thing you want to make sure is that it's a binomial. The second thing is to make sure that both terms are perfect squares and that subtraction separates the terms. In our example down here, x squared minus 16, all three of those factors are present. So what we do is follow steps 2 and 3. Step 2 says to open our two binomials, our double bubble. Okay? And then for step 3, it looks lengthy, but it's actually very easy. All we do is first take the square root of the first term, which is x squared, and we write that first. Then we take the square root of the second term, which is 16, and the square root of that is 4, so we put that second in each set, and then you just make one of them an addition and one of them a subtraction, and that's your final answer. And if you ever want to check, you could just use the distributive property or FOIL to figure out if you get what you originally started with. So now that you have that basic information, I want you guys to try the following examples on your own. So pause the video and try these examples on your own, and then we'll go over them. So hopefully you've taken some time to try these examples, and we're going to go over the answers now. So the first one, a to the fourth minus 25. First of all, I know it's a difference of two squares because it's a binomial, both terms are perfect squares, and I see subtraction. So to factor that, I open up my two binomials, a to the fourth, the square root of that is a squared. Remember, with variables, if they have an even exponent, they're perfect squares. You just cut the exponent in half. The square root of 25 is 5, so you put that second, and one of these should be plus, one of them should be minus, and there's your final answer. For the second one, x squared minus 36y squared. Again, both terms are perfect squares, it's a binomial, and they're separated by subtraction. So I open up my double bubble. The square root of x squared is x. The square root of 36y squared is 6y. Sorry about the handwriting, I'm using my fingers to draw these, and it's not very easy. Anyway, you make one of them plus, one of them minus, and then you're all done. Okay? Now the last one is actually a little bit tricky. Now, I'm going to tell you the answer you probably did get, and then the answer you should get. Most of you probably, when you did this right away, you noticed that 4x squared and 100 are both perfect squares. So you wrote an answer 2x plus 10 times 2x minus 10. But I'm going to tell you right now why that isn't factored completely. Okay? You might notice in both binomials, the terms 2 and 10 have a common factor of 2, which means that you could factor out a 2 from each binomial. So what that does, by factoring out a 2 in each binomial, you actually have 4 that you've taken out total. So take a look at the binomial again, 4x squared minus 100. Ask yourself, do they have a greatest common factor? Do they have any factors in common? You should notice that 4x squared and 100, while the 100 doesn't have any x's, they actually share a common factor of 4. So you're going to factor that out first. And what you're left with is x squared minus 25. And then it looks just like the example above, right? So what you do is you keep that 4 outside and then factor the x squared minus 25, which is x plus 5 times x minus 5. Okay? So those are the three examples I want you to make sure that you can do. One thing to keep in mind that I don't want you to get confused about, in all of my examples I did the plus first and the minus second. It does not matter which one you make plus and which one you make minus, as long as you have one of each. Okay, so that's a difference of two squares.